Hey guys, Mrs. Traver here. We're going to work through some notes on section 1.9. This is graphing quadratic inequalities. These are going to be the same as when we graphed all the rest of our quadratics with the three formats, but the only difference here is we're going to be worrying about if we're bolding our line in with the or equals to symbols, or if we're going to dash it, as well as shading. So that'll be the only extra thing. We're going to work through one example of each standard, vertex, and intercept form. And here is our first one. So we've got y is less than or equal to 2x squared minus 12x plus 3. And with these guys, our first thing we want is our vertex, which we can find h by using the format negative b over 2a. And in this situation, our b is negative 12, so I've got negative 12 over 2 times 2. So positive 12 over 4, so that'd be 3 for our h coordinate. From there, we can also go out and find our k that goes with it. So k is equal to, well, if h is 3, then I plug that 3 in, I substitute it in for each of these x's. So k is equal to 2 times the quantity, 3 squared minus 12 times 3 plus 3. Some PEMDAS can happen here, or some calculator plugging in, and we will get a negative 15 out. So I've got my vertex. We need a few more points in order to make our graph be more accurate. So let's give ourselves an XY table. I'm going to draw it horizontally this time. I kind of get in the habit too often drawing it vertically. And I know some of your books will give it to you like this, so we'll do it like this time. I want my HK to be in the middle of my table. And then I can go find something to the left of 3 and to the right of 3. So let's plug in a 2 and a 1 to the left, and let's plug in a 4 and a 5 to the right. So we can work this out by hand by plugging in 1 for every one of the x's and simplifying, and then 2, and then 4, and then 5, or we can make use of our graphing calculator. So I'm going to do that. If you go into your y equals, I wish you guys could see that. There, I'll hold it like this. If we go into our y equals and plug in the function that I have, then we can go ahead and ask for a table ourselves. So notice there's table in blue, so hit the blue second button to get to it, and then there's this vertical. So if I want an x of 1, here it is. When x is 1, y is negative 7. When x is 2, y is negative 13. And then they should match, and they do. So 4 gives me a negative 13 again, and 5 gives me a negative 7 again. So from there, I've got 5 points that I can plot. It's nice to consider what quadrant you'd be living in. So as a reminder, our quadrants go 1, 2, 3, 4 around counterclockwise. So it's nice to kind of consider what quadrants you're in. All of these are positive, comma, negative. So positive, comma, negative, that would be in quadrant 4. So let's kind of focus in on quadrant 4 when I do my graph. So I know I don't need any other quadrants, so I'm going to kind of give myself enough room to make that happen. I need to get all the way down to negative 15, so I'm going to count by 2s. Make sure I have enough room for everything. All right, so let's do something a little different. I know I want to count by 2s for my y's, so let's do that. Negative 2, negative 4, negative 6, and so on. But my x's don't necessarily need to be counted for 2s. So let's actually stretch our graph, and let's leave our x's as units 1, 2, 3, 4 like normal, and we'll just stretch our y. The SAT does this often, where it leaves one of your axes normal and it stretches the other. So it's good to see an example like this from scratch. Let's go ahead and plot all our points. I'll freeze my screen. Go ahead and do so. All right, so here's what mine looks like. Hopefully yours looks similar. From here, the only thing that we need to do that's left is, let's see, we had a less than or equal to, so I do need a bold line, and I have that. And then I just want to check and see if I'm going to shade in the inside or on the outside. So to do that, let's check a point. Let's check. It doesn't matter what point as long as it's not on your quadratic. So let's pick like some point in the middle here. Maybe we check 3, 0. So let's check this point. So check 3, 0, and let's make a note that that is on the inside. So if we do this, then we are saying that x is 3 and y is 0. Let's plug it into our original quadratic, and we'll see if it gives us a true statement. So I'd have 0 is less than or equal to 2 times the quantity 3 squared minus 12 times 3 plus 3. Some arithmetic here will give me 0 is less than or equal to negative 13. But the thing is, this is a false statement. So because it is a false statement, we do not want to shade in the inside. So we picked a point on the inside. We got a false statement. False means don't shade the inside. So don't shade the inside means shade the outside. All right, that's the first one. Let's look at the next one. This one's going to be in vertex form. So this one's in vertex form. It's going to be y is greater than the quantity x minus 3 squared minus 2. And what's nice about vertex form is we already have our HK. We already have that to get started. So we can note that our vertex is at positive 3, negative 2. As a reminder, our vertex form is a times the quantity x minus h squared plus k. The x minus h on this inside means grab the opposite of what you see for your x coordinate, and then the regular k. So we already have this starting off for us for our table. So we can put that in the middle spot right off the bat. So here's our vertex in the middle, 3, negative 2. And then let's pick our points to the left and right. We'll do again 1 and 2 and 4 and 5. Take a moment and plug these guys into your table and see what you get for coordinates there. All right, so on this one, I've plugged in my values, and I have points that are mainly in the first and the fourth quadrant, so we're on the far right of the graph. So let's make that happen when we draw our graph. I don't need anything on the left, and I need to go down at least to negative 2. So that should be good for us. Let's plot all our points. All right, so I have my points plotted, and then notice that I'm going to dash this line because it is strictly greater than. We can't bold this line in. And the last thing we want to do is check. Let's check any point. A nice point that's easy to calculate is 0, 0. So let's check 0, 0. Which note that that is on the outside. So if I were to plug in 0 for all the x's and 0 for the y, I'd have is 0 greater than the quantity 0 minus 3 squared minus 2, which gives me is 0 greater than negative 3 squared is 9, 9 minus 2 is 7. Is 0 greater than 7? That's false again, which leads me to say don't shade. So don't shade the outside. That means I should be shading the inside. All right, we've got one more. Our last one here is going to be in intercept form. So we already have 2 intercepts right off the bat that we can graph. And I noticed that it's going to be stretched out and stretched out horizontally. It's like we pulled it apart like a rubber band. So let's try that one. So because I'm in intercept form, I'm able to grab both those intercepts at negative 2 and positive 1. Now let's go find our k by grabbing p plus q over 2. So that's negative 2 plus 1 over 2. Negative 2 plus 1 is negative 1. So I've got negative 1/2 for h. Go ahead and go find k. So I've gone ahead and found k. I got 9/8 or 1.125. At this point, I've got 3 points I can plug in. My vertex, my x-intercepts. It's mainly going to be inside the bottom 2 quadrants. So let's go ahead and get that going. All right, I made a little mistake there, but I fixed it. And lastly, after we plug those points in, if I were to check 0, 0, it would give me a true statement. So I'm going to shade below. Sorry, I went a little fast for that last example, but I hope these look good. So it's normal graphing, except lastly, we're looking at shading by plugging a point.